Good morning, good afternoon, and good evening, depending on the time you're watching me. Welcome to VINDAL'S Concept, and I am very glad to bring to you the first practical on Neco 2023 physics practical. This is a guide. It is there to help you. Please stick with me to the end of this class because I'm going to explain everything and also follow up videos for the kind of calculation and questions that will be coming out from this experiment. Now, moving on, with this, we have the list of apparatuses. The meter rule is the rotor stand, stopwatch, mass hanger, clamp, spiral spring, pointer, set of masses 50, 70, 90, 110, 110, and 130, and the plasticine. Now, these are what are given to you. There are many of them you can improvise. You can improvise for clamp. You can improvise for rotor stand even. You can even improvise for that. But you cannot improvise for stopwatch because you need stopwatch to find that. You can also not really improvise for meter unless you can use any other thing for measuring your meter. And also the masses, you must get them. Plasticine, you can use gum, you can chew gum like the one I'm using just to attach it. I will do that because I'm going straight to show you from the build up, whatever I did from the beginning to the end. Now, this is what I came up with, knowing that these are the apparatus given. Then the first one is the rotor stand, then the clamp, which I'm using to hold my meter rule. And you may decide to put your clamp here, you may decide to keep it at the bottom. It doesn't matter where you put it. The main thing is keep your meter rule so that the pointer can be able to be recorded from that place. And then this is another clamp, probably another clamp, or wherever you can hang your spiral spring, because this is the spiral spring. And then this is the mass hanger. I will also show you the kind I am using. Then the method, maybe what they are looking for in this case is so many things. Can be verification of Hooke's law, where he said that the force is directly proportional to the extension, provided the elastic limit is not exceeded. You can also go that. Now, he said ignore the masses, ignore the mass of mass hanger. Attach the hanger to the spring and note the position. The first one is you will not put any mass, but the first one you just hang your spiral spring with the mass hanger together so that you will know where this pointer is pointed to, so that you will record the position. I also want to advise, let your meter rule, let 0 be at the top, while 100 be at the bottom, so that as you are loading your mass is depressing, you'll be knowing a positive difference, even though there is nothing like negative difference in mass, in length, due to the physics principle called parity. Anyways, we also have add 50 gram mass and note the new position. So when you now hang 50 gram mass, you note the new position, and then determine the extension. So when you know that, you now say the one that 50 gave you minus the one that only mass hanger gave you. Find the extension caused by 50 gram. Then you record it because we are asked to record that. He said repeat this experiment for after 50, put 70, put 90, put 110, put 130, and record their extension at every point. Now plot a graph of E against M. Determine and the slope, also determine your slope. If there is extension, we'll find out. Yes. Then repeat the experiment for a load. So this is where the stopwatch comes in. You put the load 100 grams, then find the extension of the 100 gram, then depress it a little low. Don't go and pull it too much. No, little. You make 100, you count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. For 10 oscillations, you record the period. How do you record the period at that time? I will show you on the table because I'm going to be recording anything I find out from my practical. I'll be doing the recording here. This is where my table of value will be, or I will choose here for my table of value. So then when you do that, you now have this evaluation where T2 is for 130 grams, the oscillation and the time of 10 oscillations for 130 grams, and then this T1 is the period for 10 oscillation of the 100 gram. Where is the 100 gram? Yes, 100 gram. So we now do this. I will also show you how to trick this experiment. You just do one and use your trick to generate your table for other ones. Stick with me as I get it through. Please don't forget to like this video, comment and tell us how your suggestion. Be very civil in your comment, and also make sure you share it and always return to view, because this channel is all for your benefit. Thank you, and stick with me as I take you to the physics graph. Stick with me as I take you to the physics lab. Okay, see how I'm using to hold this is called the rotor stand. These long ones you're seeing are called the clamp, because see where it can use to hold something. Though the split cork was not used in this experiment, but please forgive me. I want to use split cork to be able to hold my spring very well, and I'm going to show you how I use that. Okay, I decided to use a split cork. Then see, if I remove this thing now, you see, I have to use my strange rope, tie the split cork here. Okay. This split cork has some opening, So all I do is, inside that opening, I'll carry the rope and then make it pass through inside that opening I made on the split cork, so that it can be like this, and I will pull it up, pull it up like this, okay? Then I'll use my clamp like this, then hold it. So I will now keep it like this and tighten my clamp. Yeah. Then I'm going to use it now to hang on my rotor stand. And also remember that my pin has to go to the other part through the plasticine which is attached at this point. So that's what I'm going to do. Okay, so I will now go to my rotor stand. This is my rotor stand. There is a hole there, there is a gap there. I will put the clamp. And then tighten it. Okay, so let me turn it like this. Good. I will keep it like this, okay? And then tight it here. So I will tighten it very well. Then, knowing that this is well fixed at this point, and then so this is what I have here. Then if you see very well, see where I put the other one. Now the next thing I'm going to do is use my mass hanger. This is my mass hanger, and if you check very well, the mass hanger has a small gap there. A small gap there where I'm going to put my mass, slot it. Now see, with this place, I will just, there is that small gap. So it's from that small gap too that it come out. This is called the mass hanger. Okay. If you don't have mass hanger, you can also have a escape pan. Escape pan can also help you to do it. Okay, so I'm going to place my mass hanger through the space there in the spiral spring. So see the way I put it. Now, I think everything is good. Everything is set now. Oh, wait. Let me do it well. Okay, there is a small hole there. See, I'll slot it this way. Then, I may not even need that plasticine. I may just carry this thing now and slot in this way. Okay, and make sure your pin. Then I will now use this. Oh God, however, I'm going to do all. My intention is to make sure that they are all fixed in a certain way to avoid inconsistency in their. So I think I'm good like this. Okay. Okay, so the next thing is my meter rule. I will now carry my meter rule, put here, maybe loosen it so that it can enter. I'll place it like this. But you have to do it like this to face the pin. Then I will loosen it. I will tighten it. Until it clamps my meter rule well. My first thing, after setting up everything like this now, my first thing is to do the number one, attach a mass hanger to a spring. Note the position of the spring. So let us find the position of the spring. So with my mass hanger, I'm recording 63. It's 3.7 approximately with my mass hanger only, without hanging anything, any other thing. So that is the first one. Now I've slotted in 50 grams. As you can, with the 50 grams slotted in, with the 50 grams slotted in, so I'm seeing an extension which is 64.3. So first position is 63.7. That is when I did not hang any mass. Now that I hung 50 grams, I had 64.3. So what should I do? I will now say 64.3 minus 63.7. I will have 0.6. Let us go and hang 70 gram and see what extension it will give up.
Okay, I'm going to be hanging and be reading them. This is 70 now. You have read 50. I guess you have read 50. This one now is 70. I'm going to zoom the meter rule for you to see the length when 70 gram was hung. So when you get 50 and 20 gram, so that is 64.6 or what? I think 64.6. But I'm going to show you the full table, but I want you to follow as well. Now I've hung another one which is 90. The two masses on top, they are 2020 plus the 50, which is 90. Now under 90, what do you see? 65. Are you seeing 65 cm? Maybe. I don't know what you call it. I will show you my table as well. Under 90, you are seeing 65, or you are seeing that. So this is 3 now. 20, 20, 20 is 3. 3 is 60 plus 50, 110. This is 110. What is your own measurement? I am seeing 65 point. Is it 65.8? If you are 65.8 or whatever you are seeing, I will show you the table for us to know if you are getting it. I am adding another 20 to 110, and that is going to be 130. Let me see what your measurement is going to be like, but I'm going to show you the meter rule for you to see. Okay. This one is okay. This one is 65 point something. I want you to do it yourself. You can zoom your video and do. Okay. Based on what we are saying, the initial position was at 63.70. That was the main place. And if you also go to the instruction said attach the mass hanger and note the position. So the position of the mass hanger was 3.70. Then the next one is we should add 50 gram. When we added 50 gram, we had 64.30. Now, when I do 64.00 minus 63.70, I have 0.60. That is 0.6, which is my extension. When I added 70 gram, I had 64.60. And then when I minus it from 63.70, yes, minus from 67.70, I'm going to have 0.90. Then when I go to 90, I will have 65.00, 6500. That is when I hung 90 gram, and then I have 63 point, minus it from 63.7, I have 1.30. So, and I did the same thing in 100, and then have the extension. From that place, added E. On the column of E, I'm going to have all those things. That is exactly what my experiment is asking me under the extension. And if you look at the table, they are all correct because it is consistent, increasing in number. As the force is increasing, the extension is increasing, which is true for verification of Hooke's law. Okay. So now the next thing we are going to do is to repeat the experiment for a load of 100 gram. So I'm going to repeat the experiment by removing all the ones I was doing before. The same thing I was doing, but I'm going to remove all this. Okay, as I remove all the masses now, I am going to repeat the experiment. But I have to make sure that the pointer level does not change. If the pointer level changes, my extension will no longer be consistent. So the pointer level is very important in this experiment. In fact, it's going to mark one of my precautions. So my pointer level has to go back to 63.70 as my initial place. If it is not, I have to adjust it and make sure it goes back to 63.70, so that when I hang my 100 gram, I will be able to carry out my oscillation, 10 oscillations. So I have to adjust my pointer level to get to that 63.7. Okay, what I mean is this. If 90 is 65.00, when I hang my 100 gram, which I'm going to use to do 10 oscillations, I'm supposed to have something close to 65.4, but it will not be more than 65.4 because 110 is 65.4. So 90 should be around 62, 65.3 or whatever. So my initial position is very important in that case. In fact, if it is disturbing you, read it off. Read it off. Read it off from, if 90 is 65, then and 110 is 65.4, then 100 should be around 65.3 or 65.2. That is what I am trying to explain. Okay, I will record my 10 oscillations. But first of all, let me give you the way the new table is going to be. For that number 5 experiment, I'm going to record my mass, which is 100.00. The next one is going to be extension, if it is necessary. I think the extension is very important because I have to find the difference of extension. So that extension there is very important. So I have said it before. That means my extension should be around 1.1. Yes, extension should be 1.1. And that is the unit of measuring E. The next thing there is my time. The time where I'm going to record with my stopwatch. Please, I want to adjust the video so that you see what I'm recording there. Okay, so my T under seconds is what I'm going to determine now. When I hang 100, okay, that's my stopwatch. Let me carry my stopwatch. I'm going to go for 10 complete oscillations, but it's going to be a very small oscillation, as you have seen there. I will count my 10 complete oscillations, and what I had was just 2.7. I'm sorry I'm not showing you my recording, but you can use any electronic stopwatch to read it because this my own is somehow hard to read off. So that is for 10 complete oscillation. And I'm going to measure my period. You know period, when we talk about period of oscillation, is going to be capital T, which is time over number of oscillation. But my number of oscillation in this case is 10. So if my time is 2.7, then my period is going to be divided by 10 is going to be 0.27, which is my period. Period for 10 oscillation under 100 grams. So that is what I am asked to find out. Then I think I will also square it. Okay, let's keep going. I am going to add 130. Okay, when I want to look for some masses of let's say 30. So to get 30, if I have 120 and I have to get 10 to be able to get 130. So I'm adding 10 grams and 20 grams. So when I add them, I am going to also do a little oscillation, very small oscillation, 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, I am going to record. I think that was 0.3. 3 seconds. Under 130 is already, extension under 130 was already measured at 2.1. So I'm not going to look for another extension. So it's going to be 3 seconds for the time of 10 oscillations. 3.00, and the period is going to be 3 divided by 10 3 divided by 10 is 0.3. So that is going to be my capital T, which is my period. Then I'll also find T square. And then I am done. I think the work is coming to an end. So the next thing is I'm going to plot the graph. And when I plot the graph, I'll have my record, which I'm going to use. But remember, they say we should find K. Let me remove this thing so that you see what I want us to find. Now you are seeing K. K, which is equal to 39.5 x. What is the x there? X means the extension under 130 minus extension under 100 gram. So when you say 2.1 minus 1.1, the answer is 1 cm. And that 1 cm is the x. Because they told us to find that in the question. 1, good. That one, so I'm going to find the period under 130, which is 0.3 squared, which is going to be 0.09. 0.09 minus under 100 gram, the period was 0.27, which is, when you square it, you are going to have 0.0 to 0.07 approximately. So when I do the experiment, I'm finding K. So this is 39.5, and 0.09 minus 0.07 is going to give me 0.02. So 39.5 divided by 0.02, I'm going to have around 39.48, and that is going to be cm per seconds. If I convert it to meter, I'll be having around 19, and that is what my K is. And remember the unit, cm per seconds. And thank you very much for being part of this class. Remember, I'll be coming with a hack. You don't need to perform all this experiment to get your table of value. I will be coming to perform a hack on how you can do that. And also going to plot this graph. Plot the whole of graph to show you how to plot graphs. Well, somebody was telling me to plot a graph. If you are watching this video, you know that is specifically for you. I'm going to plot this graph. Thank you very much for being part of this class, but please don't forget to